Now coming back to measurement of central tendency. The first measurement of central tendency is the mean. And how do we find out mean? Before we find out mean, let's put some data here. So I have put data here. This data is related to student height. Either I can copy this, let's say if I can copy this and paste it here and press enter. Now what happened is, in the vector named as student height, these particular heights have been added. So if I put student height, and once I am halfway down, I can just press tab to fill it and then enter. So this gives me that in this particular vector these are the numbers. So the other thing I can do is, in the script window itself, I can select this particular line and I can press Ctrl and enter. So this also will do the same thing. So now I have student height, and now I need to find out mean of all these student heights. So for that I can use the function which is mean, and I can type here mean, and in the bracket now I can put student height. Now if you are wondering that should I be putting the inverted commas here, let's say like this. No, you don't need to put inverted commas here, because now student height is a vector. It's a name in which you have all your data. You need to put inverted commas when you are putting something called as character. Student height is not, student dot height is not a character. It is a vector in which you have all this information. So for this you don't need to put single quote or double quote. You don't need to put that. So now for mean, what I have done is mean, and in the bracket I have put student height, and with this if I press enter, this will give me the mean of all student heights. So mean is 110.222. And if you see environment here, in environment student dot height has been saved as a vector. Here I have entered 9 students height, but what happens, number of times you will have this information which will be a large number in an Excel sheet which you will be importing here in R, and you will be working on that. When you are importing Excel file having a lot of students heights, let's say 1000 students height, 1 or 2 of those might not have height. So these might be blank fields. Anything which is blank when imported to R becomes NA. Now question comes that when calculating mean, should NA be counted as a number or not? So to understand that, let's take this one. This is student dot height 1. So now in this new vector which is student dot height 1, we have 9 items which we had earlier, but in addition to that we have NA as the 10th item and 1047 as the 11th item. NA is not available, so the height of 10th student was not available, and 11th student height is mentioned as 1047, which seems to be a mistake. Now what we do about NA? Now if I want to find out the mean of student dot height 1, so I will type mean student height 1, and if I press enter, this gives me NA. So now I need to find a way to remove NA from this list. This list, again I am saying, is a small list, but let's say once you have 10,000 students and height of those, many of these might be missing field, and once these are imported to R, those becomes NA. So you need to take care of those NAs when you have a large number of data. So let's see what you need to do to remove NAs from that list. So this is something which I did earlier, student height, but here if I put NA dot RM, which comes here, is equal to true, that means remove NAs from the list, and with this parameter if I press enter, now NA will be removed from these 11 numbers and we will be left with these 10 numbers, 9 old numbers plus 1047 which was the last number, and with this I find the mean as 203.9. Now another problem remains here is that this height is too much because of some extreme value, and that extreme value is 1047. Mean function in R gives you that facility where you can remove extreme values, because extreme values can affect the mean. This is student height. Maybe if you are looking at the income of people and 1%, 2% which have come in the group as a very high income, you want to remove those people from the group to find out the mean, so that you can really make a good representation of the people. That mean should not be affected by those extreme values. So what you can do is you can trim this data. When I say trim this data, you can remove, let's say, 10% of the top values and 10% of the bottom values. If you want to remove, then you can use trim function and add trim is equal to 0.1. So 0.1 means 10% from the top will be removed and 10% from the bottom will be removed. So let's do that, and here let's keep that NA.RM is equal to true, and in addition to that I add trim is equal to 0.1, and 0.1 is 10% from the top, 10% from the bottom, and I hope with that 1047 will get removed from the list. Let's see, and now here I get 111.9. 111.9 is something similar to 110, because from the top 1047 has been removed, and from the bottom, which was the lowest one, which was 100, so that also has been removed. So with that, instead of these 9 numbers, now you are left with these 8 numbers. The average of these 8 numbers is 111.5. So this was all about the mean, where you can find the mean, where you can do the trim mean, and you can remove the NAs from the group of data.